right, so we're looking at section 3.3, part 1 today. And our goal is we want to be able to solve quadratic equations using square roots and also using completing the square. I've been asking people today, and it seems like about half have used completing the square and half of you have not. So we'll see how it goes in here. The first thing we have to recognize are what we call these perfect square trinomials. So I want us to factor this. So set up your double parentheses. We look here first. X times x is x squared. What are numbers that multiply to be 1 and add to be 2? 1 and 1, right? So we're going to write this as 1 and 1. When we check the outers, we get 1x. Inners is 1x. So if I want to get positive 2, what do the signs need to be? Plus on both. So another name for this is x plus 1 quantity squared. That's what we're trying to do. We're trying to get it as some quantity squared, because that's going to make it the best for us when we're trying to solve. What about this one then? If I set up my double parentheses, I look here first, x and x. What are numbers that multiply to be 4 and add to be 4? 2 and 2, right? The outers give us 2x and 2x, so how would I get a positive 4? Plus and plus, right? So this is going to be x plus 2 quantity squared. So what we're looking at then is how we can solve these quickly. We don't want to have to go through that every time. So look at this pattern. If we take half of this and square it, do you see how it's the same as that? Like, what's half of 2? And square that. So if half of this number squared is equal to that, then we should be able to go directly here. What's half of negative 6? Negative 3. And then square that. What's negative 3 times negative 3? Positive 9. So this will go directly into what? X minus 3 quantity squared. So it's always going to go this way, guys. It's going to go the square root of this sign, and the square, and this the square root of that. So look again, square root, first sign, square root. That's how we can go quickly instead of having to write all that out. So what's the next one going to be? What's it going to factor down into? Okay, just x minus 4 quantity squared. And if you get stuck on it, just go ahead and set up the double parentheses. Think what times what is x squared, x and x. Numbers that multiply to be 16 and add to be 4, or 8, are 4 and 4. And we need them both to be negative to get the negative 8x. Okay? All right, so what do you think this would multiply out into? Can you go the other direction? Like this went to this. These are equivalent. Can you quickly think of what this would be? What do you think, Max?
X squared plus 10x.
Good job. So that would be equivalent. I don't need parentheses on that. Okay, everybody try this one. Think of what it would be. Anybody know? Natalie? Good. Okay, so now we're going to be using this when we're doing these kind of problems down here. So I can see that right here, this is one of those special perfect square trinomials. So how can I rewrite this? Look up above. How did we rewrite it? Another name for this is x plus 2, then what? Squared equals 7. This is now a problem like what we've done before. How do we solve a problem like this? Square root this side and square root this side. And so now we're going to have x plus 2 equals plus or minus radical 7. And we're trying to get x by itself. So what are we going to do? Subtract the 2 over. And always put the 2 first. It becomes negative when we pull it over, and then plus or minus radical 7. We want the rational part first, and then the irrational part second. Questions? All right, let's come over here now. What is another name for this? Here's how we do it. Square root, first sign, square root. And what's it going to be? 5. W minus 5 squared. To check it, I have to make sure that half of negative 10 squared is equal to that. I shouldn't write it that way. I should write it like this. So half of negative 10 is negative 5. Squared is positive 25. That's how I know that I can rewrite it. And after a while, you just know that it's going to, be the same. So this equals that. Go ahead and try to solve it on your own now. I'll be doing it up here. Did you get it? All right. Okay, guys, now we're going to go and talk about how can we make this into one of those perfect square trinomials. Well, the way that we do that is we have to take half of b, get half of b, and then square it. The letters are the coefficients. So the coefficient here is a, coefficient here is b, and then we're trying to find c so that this will be factorable into a perfect square trinomial. So what is half of negative 14? Negative 7. What do you get if you square that? 49. So we're going to say, okay, c is 49. And so now we're saying y squared minus 14y plus 49. What is another way to write that in factored form? Madeline?
1 minus 7.
Yes. Do you guys see how she got it? Okay. All right, do this one. Check your answer. You take half of negative 8 is negative 4 and then square it. Okay? This one's going to be a little tougher. When you take half of an odd number, I don't want you to put 3.5 or 3.5. Half of 7 can be thought of as 7 halves. And now you want to square that. To square 7 halves, you square the 7 and you square the 2. So what is c going to be? What do you get if you square both of those? 49 over 4. So that's what c has to be, is 49 over 4 to make this a perfect square trinomial. And now we're going to write it out. Square root, first sign, square root, and that's another name for it. These would be equivalent if we were to multiply that out. All right, so now we're going to actually use completing the square. Okay, the first thing that you always do is take c to the right. Take c to the right. This is a. This is the A term, this is the BR term, this is the C term. I want to take this to the right, so I'm going to add 2 to both sides. So I'm starting with r squared minus 6r equals 2. Now we are going to take half of b and square it. So what is half of negative 6? Negative 3, and square it. What do you get when you square it? 9. And we're going to add that to both sides. So I have to add that 9 to the left side and to the right side. The reason I have to do that is because I'm not changing the equation if I add it to both sides. It's still equivalent. Okay, now I want another name for this in factored form. Do you guys know how this factors? On the left, square root, first sign, square root. What is it? R minus 3 quantity squared. And then on the right, I've got 2 plus 9, which is 11. So now, to finish this problem, I'm going to take the square root of the left and the square root of the right, and I'm going to have r minus 3 equals plus or minus radical 11. And then what do I do to finish? How do I get r by itself? Just add 3. So it's going to be r equals 3 plus or minus radical 11. Okay? Have any of you seen this before, completing the square? A couple of yeses? Yeah, Max?
How'd you get the 9?
I had to take half of b and square it. So b is this right here. So I had to take half of negative 6 is negative 3, and then I squared it, and that was 9. And that's the value we're going to add to both sides. And then we're going to finish the problem after we do that. Look at another one, and I think it'll make more sense. Okay, so what did I say we have to do first? Add 4 to both sides. So let's just show that. R squared plus 8r. Take the 4 over here. We haven't changed anything yet. Now we're going to step 2. We have to take half of b and square it to create that perfect square trinomial. So what is half of 8? And then square that. Good. And I'm going to add that to the left side and to the right side. We have to add that to both sides. And now we have to finish the problem. So to finish the problem, we have to know, how does this factor right here? Well, we just talked about that in the other part. We do the square root of the first sign, and the square root of the last. And it's quantity squared. 4 plus 16 is 20. And now we just have to finish the problem. This should now be a problem we've done before. Finish it. So I had to take the square root of 20. 20 is 4 times 5. Square root of 4 is 2. Couldn't do the square root of 5. I have to put plus or minus anytime I take the square root, and then I just had to take the 4 over. Okay? Anybody get that right? Okay, guys. Let's go over here to number 8. When we look at this problem, we think, okay, it's factored over here, so can we just set y equal to 3/4 and y plus 1 equal to 3/4? No, because what does it have to be equal to, Jackson, to do that?
0.
0. If this had been a 0, our answers would have been 0 and -1, but it's not. So what we have to do is we actually have to multiply this back out, and we get y squared plus 1y. This is the c value, and it's already on the right-hand side. That's the c value, and it's already on the right, so I don't have to take c to the right. It's already over there. But I do have to take half of b and then square it. What is half of 1? 1/2, and now I have to square that. Good job, 1/4. Do I just add 1/4 to the left? Both sides, because I have to keep it equal. Do you think you can factor this right here using the rules? Ava, do you have it? Good. Nice. So she's just saying she did the square root, the first sign, and the square root of 1 is 1, square root of 4 is 2, so 1/2. And then 3/4 plus 1/4 is just what? What's 3/4 plus 1/4? 1. And now we finish. We take the square root of the left, square root of the right. What do I have to put in front of the square root of 1? Plus or minus 1. And now I have to subtract 1/2 from both sides. And I have two problems that I actually have to do. I have to do 1 minus 1/2. What's 1 minus 1/2? 1/2. And then what is -1 minus 1/2? Good job. Or you could have put -3/2 for that. Okay? All right, let's take a look at number 9. Can I just set these equal and solve it? No, I have to multiply it out. So I have 6x squared plus 30x equals -24. Now, this is the most important thing, is that if we're going to use completing the square, this has to be a 1.
All right, good afternoon, Firebirds. Pardon the interruption. But it is time now for us to reveal the results for the 2023 homecoming court.
Your sophomore
So we're going to divide through by 6.
Olivia Dawson, Madeline Kurtmeyer, Josie Usler. Your junior representative is Charlie Bechet, Katie Cozile, and Izzy Lover. And if your senior representative, Nyla Escobar, Sophia Hayes, Will Jackson, Josue Moda, and Brennan Rennie. Congratulations.
Congratulations indeed. We will be calling those individuals down on Monday to give them their information packet for planning purposes. Until then, congratulations. Thank you to all of our Firebirds who participated and voted this year. And we look forward to a very fun-filled Spirit Week next week and a homecoming celebration with the football game next week and then the dance on Saturday. We now return you to your regular scheduled, wonderful academic classroom learning experience. Go Firebirds!
All right, that will live on forever in my video. Okay, here we go. Okay guys, so all I did was I said that our coefficient in front of here had to be a 1. So do you see I just divided everything through by 6? Okay, so now before we start trying to complete the square, what's going to happen if I take half of 5? What do I get? 5 halves. I'm going to have to square it, add it to both sides. Think ahead here. If I take this back over to this side, will I be able to factor it? Are there numbers that multiply to be 4 and add to be 5? Yeah. So we are not going to use completing the square, because if I just add this 4 back over here, not something we maybe would think of, but we want to check that. See, usually the number starts over here. Now there are numbers that multiply to be 4 and add to be 5, so we can just solve it this way. X and X, what are those numbers? 4 and 1. And what are the signs going to be to get the positive 5x? Positive, positive. And so what are the answers then going to be? You got it, Hagen? What are they? Good. What's your other question?
Like, is this we're on a test, and we like work to not put it in the like second form and just keep it like with x squared plus 5x equals -4 and solve from there?
I would love that. We did that in 4th Bell, and we went all the way through, and then we realized that it could have been factored. So sometimes that's going to happen, but anytime you go through completing the square and you get integer answers, then that means it could have been factored. But so back here, could these have been factored? No, because we did not get integer answers. This one actually could have been factored, but it would have taken some more work because you would have had to multiply through by 4 and do some things like that. But okay, guys, down here, just real quick, I want to talk about the best way to solve problems. I will never tell you you have to do a problem a certain way. So like on this problem, you could complete the square, but I think it's easier just to factor out what. What do these two have in common? X. So factor out the x, and what are you left with? X plus 7. Is it equal to 0 like we need it to be? Yeah. So what are the solutions going to be then? X equals 0 and -7, right? Do things the easy way. Okay, on this one, this is already in a good form for us, because what can we just do to both sides here at the very beginning? Square roots is the way to go. So we're going to have x minus 1 equals plus or minus radical 35. And then what do I do? Add 1 over. Does the 1 go in the back or in the front? In the front, because we want the rational part first, irrational second. And there we go. What about this problem? What should I do before I do anything else? Divide it by 4. You're allowed to do that with an equation. You can just divide by a constant. Thank you. I'm going to check to see if it can be factored. Are there numbers that multiply to be 3 that add to be 2? Nope. So what are we going to have to do? Complete the squares, CTS. So what do we do first if we're going to do that? Yep, good job. Try to finish on your own. I'll be doing it up here. Suzuki? What's what?
The one from Elwood.
I had to take half of 2 is 1. 1 squared is 1. I had to add 1 to both sides. Yeah, that's the thing people forget to do mostly, is add that 1 to the right side. Okay, any other questions? All right, guys, so the homework's on Canvas. Make sure you do it on a separate sheet of paper, because this is not something that we can just take lightly and go through real quick. You got to work your way through it.